You can close out right here.
Hey, you got the
Hey,
notes.
Jen.
So you got to click share the screen. Perfect. Full screen. Good. It says share. All right, so Phil's ready to go. And so I'll do a quick introduction. Hey, everybody. We're at JS Meetup, December 2019. Thank you for coming out. I know it's hard for some of you to get here. I know that the weather's getting better, but it's also been worse. So we live in Syracuse. Regular. There's some real people in Syracuse here tonight. A lot of regulars, and in fact, the one who's a new regular would be Caleb, our first time showing up and first time speaking. This is Caleb's first time doing the talk, so it's all recommend. And afterwards, give feedback on what we liked and make sure that he knows that we're all listening. So his talk is on functional programming in JavaScript or functional programming. And,
Looks like I misspelled that.
So with that in mind, I'll just say, anything else about that? Anybody have any questions from previous meetups or anything, or we give it over to Caleb?
Okay. Looks like your video is set up more for me sitting down, so
It is.
I'll do that instead. Hi, my name is Caleb. I work at Carrier as a kind of a team lead for web apps and mobile apps. So I don't actually work with JavaScript all that much in my own job, but I'm also a self-taught web developer, and I really like using JavaScript outside of work. Primarily, I work with React.js, and I've kind of stumbled upon this functional programming thing. How many of you have heard of functional programming? Curiosity? Okay, so about half the people here. Have you used functional programming? Okay, good. And I presume that most of you use JavaScript more on front-end development for the most part?
Yes.
Okay. It's my first time here. I've definitely wanted to come to some of these meetups, but they don't line up with my schedule very well most of the time. So, functional programming is something that is called kind of like a coding paradigm, I would say. So kind of like object-oriented is a paradigm. It's a paradigm of a different philosophy. It doesn't mean, it's not mutually exclusive with object-oriented programming. Some people think it is, and certainly certain things don't exactly work together well with the two paradigms, but you can actually have a mix of both. And actually, JavaScript is a mix of both paradigms. So it allows for some functional programming, it allows for some object-oriented, but you can do a mix of both. So, these are all the things that we're going to cover today. I'm just kidding. But this is a list of some of the things that you may see if you were to research functional programming. And they look absolutely ridiculous. And that's because functional programming is really developed by people in the academic realm, I would say. So you may have heard of a math called category theory. Functional programming is kind of derived from category theory. It's a very abstract, high-level, logical way of thinking about things. And actually, if you guys know Alan Turing, who invented essentially computing as we know it, his mentor, I forgot his first name, his mentor's name is Church, last name. He invented something called lambda calculus. And it looks like some people know what lambda calculus is, but essentially, he could define all of computing with a single function. And that's where we get functional programming from. And so the whole idea is it's very mathematical in nature. I kind of am a really large geek, so I love math. And I really like researching about functional programming. And actually on that point, when Turing and Church were coming up with their computing methods, they were actually both trying to solve the same problem, the decision-making problem. And they both solved it and proved it, but using two different methods. Church used his lambda calculus, and Turing used Turing machines. So, how many of you have ever seen something like that before? I think probably everybody, right? I did a research on what are the top JavaScript errors, And this is some graph that I found. Pretty much all of them have something to do with something not being defined or something not found. So what that tells me is that there's a big problem with things suddenly not being defined. And there's a couple of reasons for that, especially on the front end. When we make, let's say, API calls or something like that, we don't always know what the data is going to be coming back. Sometimes we don't get anything, sometimes it's not well formatted. There's another way that we may have something undefined, and that's if we have code that has some shared state, and that state changes because of something else, and we didn't know about it, or another part of the program didn't know about it. And so something gets mixed up there. So the two things that I would say are the causes of this are what we call side effects and shared state or mutability. And so the solution to that is pure functions and immutability. So pure functions essentially prevent side effects. A pure function by definition is a function that doesn't have any side effects. And now I have to explain what side effects are. Side effects are pretty much anything that the function does that is not exactly related to its input and output. So I'm going all the way back to math when we first learned it and we learned about functions. Back then when we learned a function, it was a black box that you put an input in, you get some output. That's essentially what functions are in functional programming. So you can't have add x plus y and log it to the console. That's a side effect. You can't have add x plus y and do an API fetch call for animated cat GIFs. So you can only take your inputs, do some mathematical operation on it, some sort of operation on it, and then give it an output. Immutability means you can't change things. So everything is constant. If you want to add an element to an array, you need to use a method that creates a new array with that element in it and gives it back to you. So it sounds like a lot of work, but what that really prevents is it allows for an extra level of determinism, that we know that everything, we don't have any shared state, we don't have any side effects, and we know exactly what our program's going to do. In actual functional programming languages like Haskell or Scala, Lisp is another example. Some of them are pure languages that literally do not allow side effects and mutability. And they are able to achieve essentially zero runtime errors because everything is fully defined. Essentially, your program can be proven logically. And so when it's run, it just runs through what was already written. And so you have no errors there. But that was a lot of kind of talk. I wanted to jump into a demo of how this can be done. So, are you guys familiar with ES6 syntax? For the most part?
Can you
Okay.
share your screen bigger text?
Yes, I can do that. If I can remember how to. Do you guys know I guess that kind of works. All right. Is that large enough? Yeah, we want. Okay, we'll do that. All right. So I'm not going to start with this. So yes, I'll use arrow functions. Fat arrow functions instead of actual function definitions because they look nicer and they're a little closer to syntax that you would actually see in an actual functional programming language. I should also go back to how JavaScript does support functional programming to some level because fortunately it's a very dynamic language. Unfortunately, it doesn't support all functional programming concepts because it's a very dynamic language as well. Because you would need something that's a little bit more structured to be able to support all the features. But one of the key things that is needed to support functional programming is what's called first-class functions, which just means that a function can be passed as a value into, or an argument into another function. It can be returned from functions, and it can be assigned to variables. That's what first class functions mean. So, for example, I guess we can use, well, so a pure function, for example, is something like const add, you know, x and y, and then you just return x plus y. So there's nothing fancy about that. And then if I do a console log of add 1 and 2, then we expect to get 3. So there we go. So that's easy enough. So that's a pure function. Now you know everything you need to know, right? Essentially, functional programming gets a lot more complicated, but really the main point is that there are no side effects and there is no mutability. It's all immutable. There are ways that in the real world we actually need to have side effects. We need to make API calls. Maybe we do need to log to a console log. And so that's where things get a little bit more complicated and you get all those fancy terminology. Essentially, the way you wrap side effects around without having side effects is something called a monad, which if you ever ask anyone to define what a monad is, they can't. It's just one of those things that's super hard to explain. And I'm actually pretty new to it as well. I've been researching this myself, so I'm not going to get into all the really deep stuff, but I'm going to get into some of the useful things that you can use in your everyday programming that are some of the basics. So we have an add function. Now, what if I wanted to create a function that automatically adds 5 to the number that I give it? So this is where I would use something called a higher order function. And that's a function that returns a function. So I'm going to create make adder. And it's going to take the number that I want to use to add stuff to. And then it's going to return another function, and say y, and it's going to add its argument to the number that I use as the add. Does that make sense what I'm doing there? Okay. So if I then create adder saying add 5, and then make adder 5, this doesn't do anything besides create a new function that's assigned to add 5, and now I need to call add 5. So if I do console log of add, and I add, let's say 4 to it, I'd expect 9 to be printed out. And instead I get not a number.
On line 20, you missed the 5 on your add function, which is only.
Line 20, you're saying?
Needs to be add 5.
Okay, I see what you're saying. Yep, there we go. There it is. All right. So this is higher order functions. You may have heard about them outside of functional programming, but they essentially come from functional programming concepts. Higher order functions?
I didn't hear what you said.
Oh, I was saying you may have heard of them outside of functional programming. But that's where they come from. It's from functional programming. If you've used React.js before they introduced hooks, a lot of ways of abstracting functionality was to use higher order functions. And so you may have seen something like with this or with data fetching and then wrap a React module or something.
Which is the higher order function, make adder or add?
Make adder is the higher order function.
Okay.
Because it's a function that returns a function. I will get to something called currying later. It looks very similar to this, and it's just really, really super useful. But instead, I'm going to jump to some things that you've probably seen, and that's map, filter, and reduce. Have you guys used map, filter, and reduce? Okay. Those are actually functional programming things. They're actually the terminology that come from functional programming. And they're not exactly implemented like they would be in functional programming because you've got array.prototype.map, array.prototype reduce, for example. So they're essentially like methods of the array type. In reality, you would have a type that is mappable, and then you would have a map function that you could then pass an array to, and it would map over that array. Instead, we have to do array.map. And that means if there was another, in JavaScript, we really only have one mappable thing anyway, but if there was another thing that was mappable, you wouldn't be able to then say map that thing. And this actually does come into play. It's a peculiarity, but it's useful when we get to currying. So we'll get to that later. So this is a array of myself, my wife here, and a couple my siblings as well. And we have just first name, last name, age in there. So you probably used map before, but one thing that we're doing here is we're actually creating a function, federal function. I'm just taking first name, and then I take that parameter, or that object, I look for the first name property of that object, and then that's what I return. And so if I'm mapping over this array, I do family.map, I just have to pass it that function, and it returns the first name. And so what you end up with is something that looks, I think, looks really clean. Sorry, I've got the second one in there too. So that just prints out the list of first names. And what I really like about this way of writing things is it looks really readable. You can say, I'm just, first name is, if I give you an object, give me the first name property of that object. And then I can say, I want a list of first names, and I just say, take my array and map over it and give me the first name. So a lot of this is just making your code look nicer. I think that if your code looks nice, then you also maybe have to reduce some of your documentation because it's basically in your code in that way. So next one is filter. So similar thing, I have a function saying can drink, and your age, the property of your object age needs to be greater than or equal to 21. So that's essentially just a function that returns a Boolean. And then I can apply that to the filter and say array family.filter can drink. And if they can, then they're alcohol eligible. And you get a list back of all the people who have an age greater than 21, greater than or equal to 21. So let me save that. Run that again. And so you get myself, my wife, and then my brother Jacob. And just so you can see, it didn't include Jason and Joanna there because their ages are lower than 21. Again, I just like how readable that is. But the last one is, so I didn't pre-write this one. We will just write it together. I'm going to say average age, something like that. And I'm going to say that this one's a little bit more complicated. So hopefully we can get this correct. The A is the accumulator, and the X is the next value in the iteration, essentially. So if I want the average, or let me make this easier, I'm going to say sum because I don't want to think about the average. Total age. All right, I'm kind of getting a loss for that. Instead, let me just write the actual the actual reduce function. Family dot reduce. So reduce takes two arguments, the accumulator and the iterator, or the value for the iteration. And then we would say return a plus x dot h. And it needs an initial value to give to the iterator, so we give it a 0. So let's see if I did that right. $106, which if you want to check, that looks about right. All close to 20, so 106. So what's going on there, if you haven't used a reduce before, a reduce takes your mappable object and then crunches it down into a single object and returns that single object. And it does that by giving you an accumulator, which you can initialize with some value. I'm initializing it to 0. And then it passes the accumulator and the next value, and then you can add them together. Or you don't have to add, you can do anything you want. So if I went in here and then, and then actually also you can pass in the index of the iteration as well. So if I wanted to go in here and make this total average age, I could divide by the iterator. I'm going to leave that total age so I don't have to change that. And iterator, I think, is 0 indexed, so I'm going to add 1. Let's see if that's right. That's right. Nope. That doesn't look right. I don't think our average age is 4. Infinity. Yeah, that's what I thought. So it is. All right. So I think, I don't remember if you can actually average as you go, or do you have to take the whole sum and then divide by the entire. There may be some math thing in there. As much as I know math, sometimes I don't know the simple things in math. But these are 3 functions that you can use to kind of, instead of if you're using a for loop to loop through everything, everything in an array and then doing something on it. Map is a lot cleaner way of doing it, and it does it in a way that isn't mutating the data, because it's giving you a brand new variable or brand new value that you can then use and pass it on to the next bit of code. And then let's get back to the previous one here. And I'm going to introduce something called currying. So instead of this make adder here, I'm going to create a different function. Instead of writing it like this, I'm going to write add as x, and then I pass it to another function, which is y, and then I pass it to x plus y, or I return x plus y. Now I can do, I'm going to use this const add 5, and instead of doing make adder, I just do add 5. So this is literally the same way of writing make adder. I just, instead of opening up the function and returning, I did an implicit return with the fat arrow function. So that's all I did. But what that means is if I do add 5 like that, this should still work. And we still get 9 as before. But instead of doing add 5, what if I did just add, which is my original function? So you can see that that returns a function. And so another way I could then invoke that is say, put 5 in parentheses there, and that's 9. So currying essentially is if you have an argument that takes multiple arguments, it turns it into a function that always accepts one argument. And so what that means is that you can then delay inserting the final bit of information. So for like the adder is a good example. If I wanted to create add 5 and I wanted to give you the second argument later, 5 plus what, that's what you would use currying for. And so this is really helpful for abstracting code as well, because you may have a lot of functions that do very similar things, but instead of rewriting it, you could use currying to create a function generator, essentially, a function that generates new functions that you can use later. Maybe we can look at another more complicated example, because this is the one concept that I think is super helpful. Let's do a function that that can wrap text in something. So whether wrapping it quotes or wrapping it in parentheses or something like that. So we can say text wrapper. I'm really bad at naming things, which is actually why I like functional programming too, because there are less things that you have to name, especially if you use something called 0 point notation. 3-point notation, that's what it is. 3-point notation is another one of those functional programming jargon things. It basically means that instead of naming your arguments and you return things, you just give it kind of a placeholder, and it just knows that it's the same type, and so just sit back. So you don't have to worry about naming your things correctly. And so I'm going to say that that takes some wrapping string. Oh, whoops. Let's say equals wrapper. And then it takes the text. And then what it does is it gives you back wrapper. Parentheses is not a good example of this, but I'll use single and double quotes because that will be. Or I'll use some other things. We'll say wrapper plus text plus wrapper. Okay. So let's say I want to wrap it in. This is just an arbitrary thing, but let's say wrap with colons. And just say text wrapper and pass in a colon. And then let's do wrap colons and give it some text. Say hello. So there it is. Wraps it in colons. But then I can use it and say instead of colons, let's say I wanted to wrap it in horizontal bar. There we go. So it's a really useful way of doing function generators. These are really arbitrary examples, but this really is useful when you have things that you want to perform on data, but you don't know what your data is yet. Or you want to, the terminology that's used is lazy evaluation. You want to wait to the very last minute to actually evaluate it. So you set up all your computations ahead of time, and then once you have the data that you need, you insert that as the last argument, and then you can evaluate the final output. So with that being said, you had a question?
Yeah.
Sure.
So in this case, order does matter because then I'm kind of understanding like wrapper, like it's taking the colon as a wrapper, the text as what they're calling it.
Right.
So so order does matter. Like,
It does
there's no
matter.
way to manipulate that, like within like how you're calling it.
I am not entirely sure. I know that there's a concept called partial application of functions. And there's actually ways of doing that in JavaScript without using currying. You kind of hijack the function prototype and you can say only apply it to this argument and then take the other argument. And in that sense, if you use that method, the order doesn't matter. But in currying, it does matter. You always want your the data that you want to evaluate, you want that to be last. So that's why I put text here as the last one. And this is why, coming full circle, this is why map is not great or map, reduce, and filter are not great in JavaScript, because they require you to put the data first. You have to do array.map, and then you do your function. So you can't just do function map and then wait until the data comes in, put that into your function, and then it just maps over it and performs your operation on it. So actual functional programming languages will always have the data put last. Those are the main concepts that I wanted to cover. Does anyone have questions on these, or?
Could you give the definition of currying again?
Sure. Currying comes from, it's named from Haskell curry. That's where it comes from. And currying essentially means that instead of, if you have a function that has multiple arguments, turn it into a function that will return functions such that each function only accepts one argument.
Got it.
And so that's essentially what I'm doing here with these two fat arrows. I could, instead of doing that, this would be the equivalent, but not curried. Because it's a function that takes two arguments and then returns something. But instead, I'm making it into a function that takes one argument, that returns a function that takes one argument, that then returns the operation. And this doesn't have to just be two arguments. You can make this as many arguments as you want to. But as you can also see, if I wanted to do, let's say I do text wrapper, I wrap, another bar in there. If you aren't creating these intermediate functions like wrap colons and wrap bar, it kind of looks weird. You end up with like a Lispy looking program with parentheses all over the place. So it will still work, but this is really helpful when you do have these intermediate things where you say, I want to create a function that's generated from a function. Yep.
Where does immutability come into play?
So immutability, currying is not a good example of that, but the map, filter, and reduce are examples where instead of going over an array and maybe modifying the elements of the array, it returns a new array with the changes that you requested. So they also, in actual functional programming, they don't have for loops or while loops either. It's all done using recursion. So it gets pretty crazy. But with that, you're essentially, you know that the value that you assign is always going to be that value. ES6 gave us const, which we can use to make things semi-immutable. It's not actually immutable. If I try and change the value of a const that's just an integer, for example, and just say const 4, usually JavaScript will yell at you. Yeah, so this is saying assignment to a constant variable you can't do. So it is kind of built in for just the top level values. So if you have an object now, you wouldn't be able to change the entire object, but you could then change properties of the object. Unless you did object.freeze, which is, again, kind of hijacking the object prototype. But you can freeze the object, and then I think you actually have to, even freezing it only freezes the top level, because you can embed objects in objects, right? So if you embed an object in an object and you do object freeze, it only freezes the top level. You then have to recursively freeze the entire structure. So immutability in JavaScript is not very well supported, which actually kind of leads into the next thing. Two libraries that you can use if you want to play around more with functional programming in JavaScript is immutable.js, which provides immutable data structures that you can use. I have not used it, and I don't know if I would personally ever use it, because what I don't like about it is that there's a concept called polymorphism. You've heard of that concept. Essentially means that you can use the same function on multiple different types, which you should be able to do. If you have a mappable object, you should be able to use a map function on any mappable object. Immutable.js, though, kind of takes the route that JavaScript does, and it provides these types that come with their own methods, essentially. I'm using object-oriented terminology, but if you have an array map and then you have an object map, for example, you can't just say map my array or map my object. So that's the downside of immutable.js. The other one is called Ramda.js. I should have had the name in here instead of just the logo. It's called Ramda. It's lambda with an R, essentially, because it comes from lambda functions. That's what the lambda is right there. And so this comes with a lot of really helpful functions that are really suited for functional programming in JavaScript. I think, if I'm not mistaken, it even has like a map function that allows you to put your data last. So you do an r.map, you give it your function, then you give it your data, and all functions are automatically curried as well. So you could say r.map and assign it to another thing, and then give it your data later, and then it would map over it and pull out the property. So I don't have a good demo of that, but definitely look into Ramda. I have not used it either, but I'm definitely looking forward to trying that out in some of my projects. Most of this has just been from a lot of research that I've been looking into the last couple months. Yes.
Could you provide a high-level example of where currying would be more beneficial than mapping? I mean, map reducing filter.
It's not exactly, you would use them together. You wouldn't use it instead of. So let me see if yes, see the problem with the normal JavaScript syntax is I can't really do that, but what I'd like to be able to do, let's say I have, I want to be able to do const get first names. I would like to be able to say map, and then let's say I have get first name and return x dot first. So I have a function that takes the object and returns a first name property. I'd like to be able to then pass that to a function and say this map function will use my function and get me all the first names of the array that I then provided. And then I'd like to be able to say just, console log of get first names of family. But unfortunately, JavaScript doesn't allow that because I have to actually say family.map. I have to put it at the front. So this is one of the unfortunate things of how map was implemented. Instead of it being a generic function that could be applied to mappable objects, it was implemented as a method of a mappable object. So it doesn't allow me to pass my data last. Don't quote me on this, but I think Ramda has a function that would allow you to actually do that. So that would be beneficial. Other things, you may have heard of underscore.js and Lodash. Those two kind of do functional programming things, but both of those, they also do currying, I think. But the order in which they accept the arguments is reversed. They always do the data first. which is the totally wrong way of doing things. So that's why I would recommend looking at rom.js over lodash or underscore. And if you guys are using JavaScript for front-end development, and you're really, really interested in doing functional programming, but you want a language in that architecture that supports that paradigm better, I've also been looking into something called Elm, which is a pure functional programming language that compiles to JavaScript and is built specifically for front-end web development. So it's a pretty small community. It's developed by one guy, but he literally is paid to just work on this. So he puts a lot of thought and effort into the project. If you use React, you may have heard of Reason React. Reason ML, which is also, it's essentially just, it's actually OCaml, just with different syntax. OCaml is another one of those ML, functional programming languages. Reason ML is backed by Facebook, so they have definitely better large corporation support, I suppose. Syntax is a little bit, it would probably be more familiar. It's meant to be JavaScript-like syntax in OCaml that then also compiles JavaScript. Advantage of that, it also can be used on the back end. Elm cannot. It also compiles not just to JavaScript, but to native binaries as well. So you can create native apps on Android, iOS, and Windows as well. So that's kind of neat about Reason ML. It's pretty new as well. It's picking up a little bit, but I've found that it doesn't, in order to get around the things that you have to do to perform side effects to API calls and things like that, it kind of has an easy escape for you, which if you have an easy escape, you might always take the easy escape. With any of these practices or paradigms, if you don't have something telling you that you need to do it that way, you may not always do it that way. But it's definitely a good thing to practice, I would say. Any other questions?
Thank you.
Thanks.
Well, that was really enlightening. I think that some things in here nobody's heard of before, so that you might have heard of and learned something new. So I could come out and say,
Sure.
Anybody have questions here on functions? We're not scheduled for another speaker, so we just got it. So I don't know if you're scheduled to. We got the rest of the night.
I was just thinking we were talking about passing functions to functions.
Yeah.
And I'm currently trying to work out some shopping cart issues on another program that I'm working with. But I was thinking that this could be a really cool way to try to figure out how to apply discounts. Like if someone is renting something for a certain number of days, that you could apply what they enter against a function and then have it spit out whether or not the discount applies.
Right.
So
yeah. Yeah, I'm sorry I don't have more real life examples in here. These are rather arbitrary and made up. If I think of anything, I'll definitely bring it back and share with the group of where I can use these.
With the you were commenting that you'd like a map function that you can pass the data to,
right,
rather than call as a method. What would be, I mean, you could write a map function, right, that you pass an array to, and then you just perform the map method on that array.
Yes.
Would that?
Yeah, I guess I could write my own map function that would do that. Yeah.
My question was.
Right. So yeah, I definitely could do that.
Yeah, I guess, but in a pure functional language, you wouldn't need to.
Yeah, so in a functional language, you have your types, but then you also have kinds of types. So for example, you would have a mappable kind of type, and that would be any type that you can apply the map function to. I guess in this case, maybe the reason why JavaScript didn't do it that way is array is pretty much the only thing that is mappable in JavaScript, the only type. Other concepts that I didn't get into here, there's something called algebraic data types in functional programming. And essentially you use a lot of basic types to create new types. And so instead of encapsulating everything in functions, they also allow you to encapsulate things in types. And there's something called pattern matching, which essentially allows you to match against all of your types. And I don't have a really good example of that here, but
Is that to determine just pattern matching? Is that so you can say, yes, this is this type? Is that right?
correct. Yeah, or this, yeah, correct. Yeah, it's to match on the type essentially. And if it matches on the type, then you can do different things. So a good example of that would be if you had a type that returned the loading, if you're trying to load some information from an API. And so you may be in a couple different states. You may be in the loading state or waiting for the data to come in. You might be loaded, the data came in, or maybe it returned with an error. And maybe that error also could be a timeout. So you could wrap that into the same type, or you could make a new one for timeout. But then you could match on those types and then cover all your bases essentially. So the nice thing about that's how Elm does it, as pattern matching. It makes sure that all of your conditions are always met. So if you miss a case, a lot of times you might forget to handle a timeout or forget to handle the API returning something other than what you expected. Then functional programming, because it has these constructs in place, catch those things often at the compile time too. It catches that as you compile. Elm has this paradigm that basically if it compiles, it will run without issues. And there are companies that use this in production, and they have had 0 runtime errors for years, essentially. So JavaScript, we have runtime errors like all the time. I work on, outside of Carrier, I work on a project with a friend of mine, works at Metis actually. I know a couple of you here work at Metis. Alex.
Alex, yeah, he told me about you.
So Alex and I work on a project does management of some of the busy work for college campus ministries, Christian ministries. And we are both not developers by education. So we really learned as we went. And so our application right now has so many errors in it. So we're looking forward to rewriting our application in something like Elm. And that's why he and I have been doing a lot of research into this before we start doing the rewrite.
You use Elm with React?
Yeah, you can. In fact, there's a React, you can inject Elm in your React app. So there's a React package, NPM package, that returns a React element, but inside of that React element is your Elm app, essentially. Elm contains its own architecture, its own runtime as well, that does kind of like how React has the diffing for the virtual DOM. Elm has something that receives messages and returns the HTML, essentially.
Cool. So you're looking into all this personally because you have an interest in reducing the runtime errors. And Elm is only one person doing this. So there's some overhead involved in doing this versus doing anything else. And do you believe that that overhead is justified for commercial production products? Is this so much better that people ought to use this?
I don't want to make any judgment calls until I actually use it. I know that there are large companies that have had a large amount of success with things like Elm. Elm is also designed because you have that React element. It's designed very well to be able to integrate into existing projects. So if you want to just test it out on a smaller feature, you can easily do that. If you still want to use JavaScript, the main purpose of this talk also is to show that you can actually do some of these concepts in JavaScript, and just make your JavaScript a little bit better, more well designed, and more, I would say the word is deterministic. If you don't have immutability, you know that your code is going to do what you tell it to do.
I'm familiar with the term side effects with Redux and
Yeah.
some of the things that's around that.
Redux was actually designed from the Elm architecture.
Yeah.
So they looked at the Elm architecture and designed Redux around that.
With the actions, you dispatch a single action and go into something that processes side effects.
Right.
And then that side effect processor would then return a new action.
Right.
So it keeps all your reducers to work without denying that you need like API requests and other stuff like that.
Correct.
You sort of talked about a monad and nobody can describe it. Do you write a monad?
So I think that I've been doing all this personal learning on functional programming. I think that in order to really grasp your mind around some of these concepts, you have to know a good portion of the language or the paradigm. So it's one of those all or nothing kind of things when it comes to learning a monad. So the best way I can describe it is it encapsulates side effects in such a way that that you are able to perform side effects, but still maintain immutability and somehow still maintain no side effects. So I don't know how it happens. I still have literally almost every day I'm looking up like, how does a monad work? Still can't figure it out.
Well, we got Joey Boost checked next week, or next month anyway, doing something really smart. He told me earlier today. For those of you who aren't aware, he's the original organizer, creator of this. He's been unable to do it. So be ready for that, get excited. And then, what else is going on in programming here in Syracuse, I think?
Is that a general question?
Yeah. I'll tell you guys one thing that I'm working on. It's called Syracuse Tech Week. There's a bunch of us working on it. It's not just me, there's like 10 people into it right now. And then we're going to place to feature programming clubs, programming companies, programming jobs, all sorts of programming stuff. Not just programming, drones, IoT. Pretty much pick a buzzword. We'll try to feature it over the course of the 6 or 7 days.